to everyone. Now, in this particular slideshow or video, I will show you the procedure of simplex that is used to get the optimal solution to a linear programming example. You can see the problem here is maximize z is equal to 1000x1 plus 1500x2 subject to 2x1 plus x2 less than or equal to 30, x1 plus 3x2 less than or equal to 50 and x1 x2 greater than or equal to 0. Now this problem has been discussed earlier in a video wherein it was solved in the graphical form. Now here we will solve it by simplex. The canonical or the standardized form of this particular example is formed by using the slack variables s1 and s2. Like x1 and s2, s1 and s2 are also positive. Now, it is maximization z is equal to 1000x1 plus 1500x2 plus 0 into s1 plus 0 into s2. If you notice, s1 and s2 have been used in the constraints to convert the constraint into equalities. Also note, normally we speak like this, that maximize z is equal to c1 x1 plus c2 x2 plus c3 x3 or c3 c1 s1 or c4 s2. So ci is your cost function that we will be discussing in the first table. Now look at the first table, the very first row, Cj. Cj is the cost function. Cj corresponding to x1 is 1500. Cj corresponding to x2 is, Cj corresponding to x1 is 1000. Cj corresponding to x2 is 1500. Cj corresponding to s1 is 0. Cj corresponding to s2 is 0. Now, we begin the first table with S1 and S2 in the base. That is, we are giving values of 0, 0 to x1, x2. In other words, we are beginning our search for the optimal solution by starting off at the origin 0, 0. Obviously, if x1 and x2 are both 0, then if you look at the constraint, you will notice that S1 and S2 take on the values 30 and 50. Corresponding to S1 and S2, you will notice in the table the value 1001, the unit matrix. And in every simplex almost, you will notice that the unit matrix corresponds to the basic variables. This is the first table. How do you compute Z? It is computed by multiplying cell by cell CB into XP. Similarly, Zj is computed by multiplying cell by cell CB into Xi. For example, Z1 corresponding to X1, that will be equal to 0 into 2 plus 0 into 1 is equal to 0. Zj minus Cj is formed by subtracting the first row Cj from the fifth row Zj. So here you will see Zj minus Cj is minus 1500. Zj minus Cj gives us an idea as to how much we can increase the value of Z. Now Zj gives us the idea of the present value of Z and the present contribution of each variable towards the Z variable. Now Zj minus Cj gives you an idea of the possible contribution of each variable towards the Z variable. So if you can see, Zj minus Cj in case of x2 is 1500. Thus x2 will be the entering variable, but we do not know which is the exiting variable. For that we will have minimum ratio. Minimum ratio is computed by taking the column having the basic variable values and dividing it by the column which is the key column. If you see, it is 30 by 1 in one case and 50 by 3 in the other case. So S2 is exit and X2 is entering, and your variable, value 3 is the key element. The next step, first since your exiting variable is S2, The second row will be the first row to be affected. That is row 2 new. The new row 2 will be formed by dividing the old row 2 by 3 or the key element. And the new row 1 is formed by subtracting the old row 2 from the new row 2 from the old row 1. Now we come to the second table. The second table has now been formed. Again, we have this value Zj minus Cj. Zj minus Cj in this particular case for x1 is minus 500, whereas for the other x2 and s1 is 0, 0 and s2 is 5 plus 500. In a way, we can state that uh, there is a possible contribution from the side of x1 still, but there is no possible contribution from x2 and s1, and s2 is, it is ill-advised to bring s2 into the base now. So once again we perform simplex. Zj is calculated. Zj is the present contribution of that particular variable towards the z value. So if you see, x2 has contributed 1500 already and x1 is only 500. S2 is also 500. So there is a contribution on part of the slack variable which is not exactly deemed uh, correct at this moment in such a simplistic case. So what we do, we compute in the same way the minimum ratio after having ascertained that the x1 column is the key column, and we note that s1 is the leaving variable. Here r1 new is computed by r1 old multiplied by 3 by 5 or r1 old divided by 5 by 3, and r2 new is computed by subtracting 1 by 3 r1 new from the old r2. Have we done? Now we have moved from the origin to the point A. Go to the graph. The other example previously we had spoken about the graphic method to solve the same problem. Now what we do, we have moved from the origin to the point A. Optimal solution. Let's go to the next table formed in the same manner. Now if you see, all Zj minus Cj are either 0 or positive. That gives us a clear indication that the possible contribution is 0, 0, or in case of S1 and S2, it is not advisable. So we stop our iterations here. And the contribution towards Z from X1 is 1000, towards Z from X2 is 1500, which is nothing but the Cj. Z value is 29,000, and in the base you will see that x1 and x2 are there taking values 8 and 14. As the optimal solution is arrived and the variable values are 8, 14, maximization of Z has taken place at 29,000. Again, to the graph. Now at this stage, what have we done? When we move from table 2 to table 3, we actually move from point A to point B.